Right, so again, the late passes, you get 42 of them, they're 4 hours each, and you apply them on your open math to the homework. There's just a little button that you hit, and and you can use one. And so if you want to use, does it give you an option of how many to use, or just?
Well, I haven't used one yet,
Okay.
but under every assignment, like when you first open it up and it shows the assignment, it'll say use late pass, and there'll be like a link or a button to click,
Perfect.
you can use it.
Excellent. All right, so you have 42 of them, 4 hours each for the whole semester. So, you don't burn them all up at once. Okay, great. So today we're going to finish up functions practice. I think we have the last couple pages to work on, last page or two. And then we're going to do composition graphically, work on that one. And then I'm going to show you guys the reflections part 1 graphically, which is going to be a homework. So we'll kind of go over bits and pieces of that. And then we'll also do reflections part 2 symbolically today. Today you have due today, My Open Math Unit 1 is due online. It's your second, second real assignment. Friday, you have the in class. So anything that says in class will be the stuff that you hand in class. And then My Open Math, I'm gonna probably drop that down to just mom, My Open Math. But for now, we'll kind of get ourselves used to this. Unit 2 is also due on Friday. Then the next one is next Monday. You do not have any My Open Math due on Monday, but you do have the in-class reflections graphically. The one that I'm handing out today, we'll have that due on Monday. And then that frees you up Wednesday, so you only have one thing due on Wednesday, the My Open Math there. Okay. So let's pop out our composition graphically. I'm going to go ahead and grab that. Oh, sorry, your function practice.
So unit 2 looking for functions, right?
Yeah, so it looks like. Looks like this. Only we're not going to do it as homework. Like yours, I think I was smart enough to take out the homework part, because we're just going to do it in class instead. This is easier. So it looks like this. Wait, it's not a homework. It's just working with functions. So go ahead and get that handout out. Thank you so much. Great. This is what we're working on now. Okay. So let's slide on down. I believe we are on the 3rd page. Right, so we did this one. And then, I think I was having you guys finish up these. Did we actually go over them in class or not? I can't remember now.
I think
Yeah, we went over those.
Okay. And then is this where we left off here?
Yeah, 6.
Yeah, so we did not do that yet. Okay. Great, so we're on the 3rd page. Great. So use the graph to find the indicated function values. So this is similar to what we did before. We've done this before, where remember f of -2. Is that my x or my y? Is this my x or my y?
Why?
That's my y, right? F of -2 means the function at -2. So in other words, it means what's my y when, what's my x? What's the x here?
-2.
-2. What's the y when x is -2? So
-3.
f of -2 is the answer, the output of putting -2 into the function. So this is saying, what's my y, right? This is the y when x equals -2. So when x is -2, again, this is my x-axis here, right? Slide along your x-axis till you get to -2, and then find where you hit the line. Slide up and down to the line. So this is at -2, comma, -4, which means that in f of -2, when x is -2, y is what? -4. Everybody good with that part? All right, so I'm going to let you guys go to it. I'm going to give you guys 2 minutes. Is that good? 3 minutes? Maybe 3 minutes in your groups to find these guys. Okay, so let's take a look at these. The next one, when f is, where is x 0? F of 0 means x is 0, so here's where x is 0. And then I'm going to have to go down to get to the number line, or to my y, to my line. So that's going to be at y is -1. F of 2, here's 2 on the number line, so I've got to go up to get to the line here. So at that point, my y, my height, is 2. Remember, x is always the one that's, x always comes first. So just think, if I were just drawing a line on the number line, would it be like this or like this? If you're just drawing a line on the number line, you just draw it like that, right? So that's your x, that's your first one. Your output, that's the second one, that's the height, that's your y. So g is -1, g of -1, sorry, g of -1, so my x is -1. So I go here to -1, and then I go down to hit the curve. So this happens at -2. G of 0, that's -3. And g of 2 is, I go up to that one, so that's +1. Good? Okay, great. Next, we're going to move on to words and functions. So verbal, we're not going to spend a whole lot of time on it, but I do want to kind of, we'll go over these together. Because they do talk about, verbal descriptions. They kind of happen, they don't happen as much in real life. It's really more word problems than this, but we'll go through it just a little bit, just together. All right, so write a function. Let me make this bigger. So, I'm going to do that. Write a function that represents the verbal function, the verbal expression. Multiply a quantity by 9. So just make a quantity x or n, whatever you want. So multiply a quantity by 9. So how would I do that one?
9x or x?
9x, exactly. 9x, perfect. And then subtract it from 11. So if you subtract it from 11, that means you take 11 and you subtract it. So if I said, I'm going to subtract, I have 12 donuts. I'm going to subtract 3 donuts from 12. How many donuts are you going to have left?
9.
9. You're going to take 12 and you're going to subtract 3. Right? So subtracting it from means you subtract it, you take 11 and you subtract it from 11. Does that kind of make sense? That's what they mean by that. So it's a little weird and strange and non-intuitive. Square a quantity. What does squaring a quantity look like?
X to the second.
X to the second. And then add it to 4. So plus 4, or you can add it to 4 this way. Either way. Either that this way or this way. Either one is fine. Okay, someone else. Divide an input by 3. Someone else besides Eric. Help me out here. X divided by 3. Done. Oh, these should be functions. So this should be f of x equals. Okay. Okay. And then the last 2, now we're going to turn the tables. We're going to say, so this one here, what's happening to x? What's happening to x? First.
Multiplier?
Yep, multiplying by what?
Negative.
Yeah, okay, sure. Multiply number by -4, sure. And then what?
Add
And then add it to 3, yep.
How do you add it to 3?
I'm sorry, what was that?
How do you get adding 3?
Because I'm adding it to 3. Or you could say, because I have -4x and is it being multiplied by 3 or is it being added to 3?
Well, it says subtract there, but,
Well, but I'm multiplying by -4. So remember, the sign always goes with the number behind it. So this is -4x. So once I multiply it by -4, then all of a sudden I have -4x at that point.
okay.
And then I'm going to add it to 3, so then I have,
I don't get why you're adding them.
well, okay, so this, if I add it to 3, then I have that. You're saying I'm multiplying it by 3? If I was multiplying it by 3,
No, I don't know, I'm saying, I don't know how the subtraction gets to addition.
it's not subtraction. Okay, so this is the same, okay, so this is -4, this is multiplying by -4 and adding to 3, would you agree with that?
Yeah,
Okay, so I can move these around if I wanted to, and I could do,
oh, it's a +3, there's a hidden positive in front of the 3, that's what you're
Yeah.
talking about, okay.
yeah, there's always a hidden positive,
Okay.
right? So I can also make this 3 plus -4x.
Um,
But usually people just, they ignore that part and just make it 3 minus 4x. Because these are all the same thing. These are all the same.
okay.
Yeah, so that's, thanks for bringing that up. Now what you could also say is multiply a number by, you could also say multiply by a number by 4 and then subtract it from 3. You could also say that as well, right? Option 2. You could say multiply a number by 4 and subtract it from 3. You can do either one of those. They mean the same thing. Okay, let's take a look at the last guy. Here, what are we doing with x?
Quantity squared?
Yep, okay, so yep, we're squaring a quantity. Square a quantity. And then what? Someone else. Someone on that side of the room.
Divided by 3?
Yep. And then divide it by 3. These are, I don't feel like these are super important. Yeah, I do want you guys to get some exposure to it, so we're doing it in class, but you're not going to have a homework on it. It's not going to be on the exam. It's just kind of, just so you're somewhat familiar with it, you see in the future, and I don't really know that you will. Okay. All right, so we are done with that handout. See if we can grab another nice handout. Composition graphically, so I think I might still have those. Yes. Composition graphically. Yes. I just got. Good. So, compositions, let's get a reader. How about Callie? Or Jenna, we haven't heard from you in a while. So Jenna, go ahead and read for us.
The introduction?
Yep.
The word composition is often used in the arts and literature. For example, a musical work is called a composition. A composition book is a bound notebook of lined paper intended for writing exercises. Art critics talk about the composition of a painting. In general, a composition may be thought of as putting together of parts into a harmonious whole, of creating something new out of existing forms. So what do mathematicians mean when they talk about composition? Well, it's not unlike what musicians, writers, and artists mean. In mathematics, composition refers to the creation of new functions by combining existing functions in a special way.
Perfect, thank you. All right, so we're combining things. All right, remember the definition of a function? It says if every value of the first quantity, the input, has only one output. So in other words, if I pop something into this function, I know what I'm going to get out. And I know I'm only going to get one thing. It's not like I might get this or I might get that. So you know for sure what you're going to get out. Then that's a function. If you're not sure, like you pop something in, you might get this or that. For example, square root. If I pop in 9, what's the square root of 9?
3.
3 or negative 3, right? So you could get two different options. You're not sure what you're going to get. So, but if I were to do squared, if I do 3 squared, I know for sure I only get one answer. 3 squared is what? 9. I know for sure I'm going to get something. So that's a function. So recall in the language of functions, we say the output, what I get out, depends upon the input, right? So the result, the output occurs as a function of the input. So that we kind of think of it that way in terms of like we input an x, and then the function gives us our output, our y. So that's why we always talk about outputs or results in terms of y. Okay. The composition of functions is a way of combining the actions of 2 or more functions into one function. So we're taking 2 or more functions and we combine those to get just one. Like a composition, right? You put together notes to make up music. Here we're putting together functions to make up a new function. All right. So let's get a reader for this one too. Gabe?
Starting with the composition of functions.
Yes.
The composition of functions is a way of combining the actions of 2 or more functions into one function. It accomplishes this by using the output of one function as the input of another function. Before we get to the how of composition, let's look at the why. Composition may seem like a rather unnecessary thing to do. However, there are real-world applications of functions that rely on the notion of composition. Example, when you dine in at a restaurant, the cost of the food and beverages is totaled, and then the sales tax is computed based on that total.
We can picture the process just like this, right? So the input, all the costs of your individual food and beverage things, and then you input those into the function thing, and it takes those and it adds them up, spits out an output, right? Your total for the bill, and then they compute sales tax and they add it to the bill, so then you get your final what you have to pay, right? So that's you can think of that as 2 different functions, right? One that adds up all the inputs and spits out a total, and the other one that multiplies the sales tax and adds that in. Right, so those are the two functions, the 2 stages. But you could make that into one process, right? Where you just add up the total cost of the food and beverages, compute sales tax on that total, and then add sales tax and spit it out. So that's kind of what happens, right? We combine that into one function. So that's called a composite function. So here we're going to look at the graphical and numerical processes only. We're going to start off with that first and kind of introduce ourselves to that slowly. Here are composition diagrams. So for a function diagram, let's see if I get this guy. Yeah, this, there we go. Okay, so this first one is function G. My input of 1, if I input 1, these are my x's. These are the y's. So an x of 1 has a y of what? Has an output of what?
2.
2. So that'd be the point 1, comma 2. Everybody follow me? Okay? So find the other two. 2 comma what and 3 comma what for function G. Write them in right here. First one we said was 1 comma 2. What's the next one? 2 comma what? 2 goes where? 2 goes to 2. So this is 2 comma 2. Right, everybody kind of following? 1 goes to 2, and then 3 goes where? 3 goes to 1. So 3 has an output of 1. Good? You guys will like these. These are super cool. They make a lot of sense. So embrace these. These are fun, actually. Okay? Now F, what happens with F? 1 goes where? 3. So that's 1 point, right? 1 goes to 3. 1 has an output of 3. 2 has an output of what? 1. Shania, what did you get for the last one? 3 has an output of what?
2.
2. Good? So those are our points. Is everyone kind of following where we're going with this? Okay. So the composition says, okay, I have 1, it goes to 2. So first I do G. 1 sends it to 2. Then I take that output of 2 and I go over to F and I input that into F. So in F, I'll take my output of 2, throw it into F as my input, and that has an output of what? 1. So in the composite, if I put them together, if I start at 1, I'll end up at 2, back to 1. So 1 goes to 1. Does that kind of make sense? You guys following where that summary? So this is sort of the long way, right? The long way goes like this. 1 goes to 2, and then goes back to 1. That's just summarized there. 1 goes to 1. What about 2? 2 goes to 2, and then goes to 1. So if I start off at 2, I'm going to end up at 1. Does that kind of make sense? And then the last one, if I start off at 3, I go to 1. And then from 1, I'll go down to 3. So 3 goes to 3, ends up at 3. Good? So it's kind of all we're saying with this. So it's all pretty cool, very straightforward. So that this composite function is just that last part, right? 1 goes to 1, 2 goes to 1, 3 goes to 3. That's just the summary, right? That's where you end up with. We call that, we did G first. We call it F of G, because first we do G, and then we do F of that. So I kind of think of it like little Pac-Man eating things, right? So first G, we do G. So G eats the input, spits out something, and then F eats that, right? So it's, this here is called F of G, right? F of G, F of G. I like to rewrite it immediately as this, F of f of what? F of g of x. So then I know, it makes it really clear to me that I do g first, right? Whenever you do anything, you start from the inside out. So I do g first, and then whatever I get for that output, right? So here, x is x. G of x is my y. Are you guys kind of following me? G of x is my y, but that y is my input, kind of my x for f. It gets input into f, and then I get my final y. Right? So kind of my first y, my in-between y, is g of x, which becomes my new x for f. So f eats that one and gives me my finalized y at the end. So to make your life easy, just whenever you see that little f of g, immediately write it as f of, right? Whenever you get this, immediately write it as f of g of x. It will save you a whole bunch of nightmare. Right? It'll just make life a lot less confusing as you're doing all your homeworks and exam stuff.
So it's like f of x.
No, f of g of x.
F of g of x.
Because they're two different functions. They can't be the same. Well, they could be the same. Well, yeah, then they're different functions. Right? F and g are not the same thing. Right? F does this. G does something different. Your G doesn't send 2 to 2, it sends 2 to 1. They're different functions. Okay, so we're going to use functions f on page 2 and composition. Oh, right, so f of g is not the same thing as g of f. G of f is different. G of f is g of f of x. So here you do this one, you do f first, right? You do f first, then g. This one up here, you do g first, then f. Everybody with me on this part? Take down notes if you need to. All right, so the inside one you do first. So if you immediately write as this other format, then just remember you always do the inside one first. Okay, let's take a look. Oh, right, so let's map that. Okay, so I'm going to look back on my little mapping thing, and we're going to do this. All right, so first I'm going to do, they want me to do g of f. So here they want g of f. That's like an open circle. It's hard to see. So it really means g of f of x, which means which one am I going to do first here? F. Great. So, and I get my sheet here, and I know we have 1, 2, and 3, and we end up going to 1, 2, and 3. This is my f, and then we have g. I'm going to kind of put it here. So g sends it to 1, 2, or 3. And then it wants to write as, what the combination ends up being. So my combination, right, what's the